Welcome back, grade 12, to Mask Miller Learning and Masky TV. I am very sure you guys, when you saw the advert, were like, why are we doing trigonometric again? Because trigonometry is very, very important, and we need to nail those graphs and make sure that we can answer the question productively. Today, I am not appearing alone, but I am appearing with Crack, the math code, and then we can be able to learn from it and understand the detail of this study guide and what we can benefit from it. Stay tuned and let's go to it. Trigonometry, as I have indicated, is one of the things that we need to know and understand, but today particularly we are going to focus on its graphs and take the questions that are inside the maths code to make sure that we can understand. But remember, the main purpose of these graphs is for you to understand the effect of the parameters that goes into the graph. So the parameter A, the parameter P, and K, as well as Q. This is very important for us to learn as well and understand the meaning of the amplitude, the period, the asymptote, the range, as well as interval. I think we have left, what is it that we have left? Okay, so the period is also there as well. This is very important for you to know that when I'm dealing with sine and when I'm dealing with cosine and when I'm dealing with tangent graphs, what is the same and what is different across all these three. Remember, this is just for them to determine or fighting and letting us know who is the best and who is greater than who. So let's look at this together as I have indicated. 1. Sine of any other angle, which in this case we are saying sine x, is what we are going to deal with. So if you check sine x, it's literally going to be drawn to this with its period starting from negative 360 to 360. But there is what we have to learn about today is actually the concept of the parameters that we have. So if you check the parameter A, that is written in blue there. This parameter A just shows the stretch of the graph itself. So what happened is, if my value of the parameter A is 1, then that means my maximum and my minimum values are also going to be in 1. So this is where my minimum and that is where my maximum values of the whole graph of sine will be. So that is the impact of our parameter A, right? So that is vertical stretch, and we have our parameter K, which literally stays in front of our angle. So if this K here is more than 1, that therefore affects the whole graph. But how does it affect the graph? In which way? If it's more there, that then affects even the period of the graph. So instead of us having the graph to have these spaces where it starts from 0 turning at 90 and go to 180, what happened is if K was 2, then everything therefore will be divided by 2 to ensure that the K then is accommodated. So it affects the period of the graph, which is the horizontal stretch. So whatever that happens here, it deals with these values that we find in this line. So it stretches these points that we are seeing here. That's why we call it a horizontal stretch. Remember, A is for vertically stretch. So it affects the minimum and the maximum values, while K affects the graph going wider in and out of that particular graph. And then now we have P. P now, it's a horizontally shift. So you need to just remember this. There is a stretch and there's a shift. So this is now a horizontally shift. What does it mean? It simply means that if I was given these values that I'm having here, all of them the way they are, what will happen is if I was given the value of P to be 30, what it means is that my point here will then move 30 units to where it has to be. So if it's say x minus 30, then it will then move 30 units to the right, because x minus 30 degrees will then be equals to 0, which makes x to be equals to 30 degrees, but positively. So it will move to the right, right? So that is what will happen. So it will move from here, go 30 units to the right, and each and every point on that horizontal space will then shift to the right in that manner. So that's what that one means. Then we have our vertical shift, which is vertical shift is actually Q. What happened is, if I then say that is plus 1, what will happen is my graph where it's standing, it will move 1 unit up. So it will move from where it is 1 unit up. That is the meaning of plus 1 that would have there. So instead of it turning here, it will then come and turn from 0, because we have added 1, and it goes up just like that until it turns from that side. And that will happen as well for our end, which is the maximum. It will add 1 up until it turns at where the 2 will be. So that is how you then read them out. And you need to know this because it's very important for us to know. That same situation will then happen for the cos graph as well as the tan graph. So you can see we also have the vertical shift, we have horizontal stretch, we have vertical stretch, and as well as we have our horizontal shift. So they are all representing the same thing. You just need to know when is it shifting and how is it shifting like that. Same applies to the tan graph. With the tan graph, one most important thing is that you need to know that there is asymptote. So the asymptote, it means that the graph can never touch this particular line. Doesn't matter what happened, but this line would never be touched by the graph, or no matter what, unless if the shift had happened, which then this particular values here, they now become our equation of our new asymptote. So if there's P there, for example, if that was x minus 30 degrees, as we have said, what will happen is that this 30 degrees will therefore become our new asymptote. What will happen is we would move this asymptote 30 units to the right for it to then be a new asymptote. So all this will move to the right for the new asymptote to be, as much as everything that we have here will then move to the right 30 units. So that's what happened, right? So you need to remember that as well when you are dealing with this kind of questions. All right. Then we do have the point where the period can change, but then please bear in mind, the reason I'm saying if it was x minus 30, it is because it can be x plus 30, right? So in between there can be either plus or minus, as well as your Q can also have plus or minus. But we have a very important thing that you need to remember as well. When you're given a particular period and you have then to calculate it or to know what new period can it be, what do we do and how do we get to it? And in this case, you can ask yourself, when I say new period equals to period of a standard graph divided by b, what is a standard graph period? That will be the table I showed you at the beginning. Remember, I said the period of a particular space. In this case, if you have 360, you have sine, the period of sine will be 360. Then you divide it by b, which will be the value that comes right before the angle itself. Okay, so let's check this example that we have here. They said sketch the following graph on a different set of x's. So this is one of the example, but then some can say sketch the graph on the same set of x's. You need to try and monitor that very, very closely, because this is your key. You are doing it on the difference or on the same. So you need to always monitor that very well, right? They gave you the interval. So the interval means that to you, that your graph have to be between a negative 360 to 360 degrees for both sine and cosine, right? And then for tan, therefore, it has to be from 0 to 360. So these are your intervals. So what is it that you are going to do? Let's write this down and then we can go check. So number 1.1, they said y equals sine of 2x, right? Let's put in the brackets. And then 1.2, they said y equals cos 1 divided by 2 multiplied by x. And then 1.3 said y equals the tan of 2x plus 1. Right, so that is what we have in this context. So let's see what is happening there. So if you check on this graph, you will see that for 1.1, what is affected is your period. What happened is your initial graph here, it was actually just coming nice. You see this, let me use a different color so you can see. You see this one that is written in the dotted line like this. The one that is drawn in the dotted line, it's our actually original sine graph, right? So that is the original sine graph. So, but what happened is when the period was affected, there was a division that happened, a divide by 2 kind of a situation, which happened there. So if we divide by 2, each and every point will then be divided by 2. So that means our point, which used to be on the 360 degrees, a negative 360 degrees there, was divided by 2 for it to move to somewhere else. So you can quickly check where is this landing and where is it starting. So that is what is happening. In that case, it has shrinked. And what does it mean? It simply means that in one circle, we are going to have 2 graphs. What does that mean when I say in one circle, we are going to have 2 graphs? So normally if I start here, and I go this way, I have my first complete graph. But the moment I do this again, and I do that, so you can see this is my full other graph that is there. So normally we would have like one like that. So that's how your graph complete in this way. So in this case, we have our full graphs that are done. So we have another graph that is there. So that is what we are saying in this case, that between the period of 360, you are going to have 2 graphs. So which is from your 0 to your 360, you have 1, which ends here. And then you would have your second graph, which is start there and then end here. So within a period of 360, you're going to have your 2 graphs, and that is what that means. So that's how you can therefore draw the graph of that. Okay, so let's check the second one. They said y equals cos. So this also still affect our period. So they said equals to 1 divided by 2. Remember, the formula for the period, we say the new period, you can find it by using the original, which is 360, divide by what is given now, it's a half. So what is going to happen here is, if I take this 360 and then I multiply it by, I divide it by a half, it's simply the same as when I have 360 multiply by 2 divided by 1, which is giving me double of what I have. So in this case, my 350, I think is going to be 540. Let me just check. So 360 multiplied by 2, that is 720. Apologies. So that is 720. So now, what does this mean? It means that one full graph, instead of it to be within 360, it will now be where it is 720. So if you check here on this graph, you can see that this is just one lap of our graph. There's no completion whatsoever. If I look only on the normal one that I used to have, you would see that this is how the graph look like. So if I do this, I have 1.5. Then I had one graph fully like that. But if you look now, what I'm having here, it's actually just a lap of it. So it's just one part of my graph. It's not my full graph. That is what I'm getting between 0 and 360. So for me to get it fully, I must have another 360 and another 360 and another 360 for me to get a full graph as I would have in this format. So please always remember that the period affects the graph itself. And for you to calculate it, you can just simply multiply or divide by that number b, which is in front of your graph all the time. Okay, this situation do happen for tangent as well. So even if you have tan, you can still have the same situation. But with this one, what happened is there's two conditions that happen, or two parameters that had occurred. So if you check with this one, what happened is, let's see, when you check with this one, what happened is there's two conditions, as I said. One is that B has been changed or is affecting the period. And then the second one is that there's a parameter Q that has been there. So there's two things that happen. The graph had been changed or have been shrinked into two within one, which is what we are seeing. If you check from 0 up until 180, you're literally having two graphs. So from 0 to 180, from here to here, you are having two graphs instead of one. So what is that? Then after that, you're going to know, okay, from here up until there, you have another complete graph. So that is what is happening, or that is what this means. But because of the +1, that means from where it was supposed to be, for example, it has to shift 1 unit. How is it shifting? Is it shifting to the right, down, up, or to the left? I said Q affect the movement of vertically shift. So that means it's going to shift 1 unit up, right? So what you had in any point is just going to keep on shifting 1 unit up, and that's what you do. So it's very, very important that when you're drawing these graphs, you put at least points that can help you to move up. And I'll show you when I'm drawing the graph myself. Okay, so let's get to this. I have went to page 288 of Crack the Maths Code, and in this I found this nice question that we can work through together. But before I get into that, I need you guys to just go into online. Do you know we do have this Crack the Maths Code? You can go shop it online with Maski Miller Learning, and Maski TV will show it to you to make sure that you can get to it. And you can get that copy for yourself in each bookstore, including P&A, so that we can do this together and crack this maths code all along South Africa and across the world. See you after the break. Yes, let's do this. Okay, we have this question in front of us. I'm sure that some of us have tried to check it out and see what we can get. So let's see, when we are doing it together, what is coming out. Consider the function f of x equals cos 3x and g of x equals sine x, for where x is an element of negative 90 degrees up until 180 degrees, and they are both included. Now the first question, they say solve for x if f of x equals g of x. So let's do that. We are told that f of x is equals to g of x, and what we have to do therefore is to solve for x. Okay, so what we're going to do first is to substitute. We know f of x is given as cos 3x, and we know that g of x is given as sine of x. All right. Now, when we have it like this, it sounds like, yo, what am I going to do? Because it's not the same ratios. Don't worry, we can always make it the same ratio. I remember there's one song that was sang by another teacher who I know he'll be saying that when you see another sign or you see a cos, just change the sign, right? Because a sine will then become cos, or cos will become sine. So usually we change the one that makes it easier for us to change. In this context, we are going to change sine. So instead of having sine, therefore, we're going to have it as cos of 90 degrees minus x, right? We agree that sine x equals cos of 90 degrees minus x. That is our co-ratio or co-function. Okay, so when we have this, now we know that all of them are the same, or we have the same ratio, more like when you're doing it in exponential equations. So would be dropping them as if we don't know they were there. So what we're going to do there, will have 3x will then be equals to 90 degrees minus x. So this is what we have in this context. Are we following? Okay, so that is it. Then we have 3x, and then we need the x's together. So we're going to add the x on our left, and then we're going to add it on the right as well. But when we do that, then we're going to get our reference angle, right? We're going to have our reference angle, and this is very important for us to jot it down so that we can know what we're going to do. So reference angle will then be 4x equals 90 degrees. When we reach this spot, we always just make sure that we use it as a reference angle to get to what we are looking for. Right, so let's write our sort of a general mini formula for us to get it right. So what is happening here is we have to say 4x equals to 90. Because we are dealing with 360 degrees, we would have to therefore add the period, which is 360 degrees, multiply by k or n, where k is just an element of any integer, right? So k is an element of any integer that we can have in the space, right? So remember, k is just an unknown number that we can substitute at any point. So since we have our reference angle and all this, what we can now do is divide both sides of our equation, or each and every term, by 4 to make sure that we do what we were asked to do, which is to solve for x, right? So we divide that by 4, and that means x will then be equals to, I think when you say 90 divided by 4, you're going to have 22.5 degrees. Just gonna quickly check that. So 90 divided by 4 should be correct. That is fine. Then 360 then divided by 4, should that be 90? Let's just be sure. If we divide it by 4, that is giving us 90 degrees. K. There's no need for me to rewrite the statement where k is an element of integers, because I've already said that. All right, so this is the value of x in a generic way, or in general formula way. But what is it that they're asking me? They want me to find the value of x where, if I had to draw the graph, I would find that f of x and g of x intersect. That's what they mean. So that cannot be only one point. What am I going to do now? I'm going to go back to my interval and remember what it is that is from and to. So any value that is between -90 or including -90 to 180, and if they are equal, right, the graphs intersect, that is the value I'm looking for. So let's jot them down. Usually I don't write it this way, but I want you guys to see and understand. So first one, I'm just going to write first one and then show you how you do. Then we use the calculator. So x will be equals to 22.5 degrees plus, then you can start saying, what if I add? What if I substitute? And what if I then, instead of k, put a -1? What will then happen? Then you start like that, right? You multiply, you use your calculator, you get them right in that manner. So here on the first spaces, I would have 22.5 plus 90. So I'm putting this on my calculator so I can just go substitute all the time. Bracket or multiply by a -1, and that gives me an answer of -67.5 degrees. Remember, that's the first one. So what I'll advise you do while you still have your calculator and everything has been there, you can just go and then you then substitute. Instead, we started by -2. You started by -1, you can put -2. You would see that -2 gives you away from the -90. It's literally giving you -157.5, which is not within the intervals that we are dealing with. So let's put 0 to check, and if you put 0, you see that the second answer, therefore, it gives you x to be 22.5 degrees, and then if you go there and you now put 1, so you just keep on putting the numbers there, or you substitute instead of k, then put 1, then you will get 120 or 112.5 degrees. So that is your third one, and then you keep on doing that. Let's see if I put 2, what is going on? I'm going to get 202.5. So 202.5 is actually outside the space where I need my answers to be. So this 3 will therefore should be where the value of x or f of x intersect with g of x. So that's how you actually deal with this kind of questions. First, you equate, you find your way into factorizations, depending on what kind of factorization you're going to use. And then you use whatever trig information you have about the ratios, and you reach where you have your reference angle together with your general formula, which is the general equation that we have. And then you start substituting your value of k all over until you get the one that are within the intervals. All right, so that's first. Then the second one, they said to us, we must sketch the graph of f and g on the system of x's and on the same set of x's. That's what they are actually saying to us. So we have to draw it, but also it has to be between a -90 degrees and 180 degrees included as well, right? So since we have done that, we have found our answers, and let's go check the graph. Should be able to find our graph there. I decided to draw the graph instead, pre-draw it, so that we can be able to talk to the graph all together instead. Okay, so if you check on this graphically as well, what we talked about initially, where we said that where f of x and g of x are equal, meaning they intersect, those were the values we're looking for. So you can check, here is one of the values there. Let's use a highlighter. Here's one of the values there, right here. This is where your -67.5 is, right? That is one of the intersection that we have found. And if you go back like that, you can see that we have another one here, which is -45, which is the opposite of the other one, which we have here, which is 22.5 as well. So if you check, you can see that we have another one here, which is 112.5 as well as 135. It's actually easier for us to find them through the graph drawing instead of us trying to calculate them. But nonetheless, that is how you get to this kind of equation, or this is how you draw your graph. Try to make sure that when you draw the graph, you show where the intersection is. You might not be able to show all the points, but points like this, which is on the x and the y axis spot, you need to be able to just highlight them and ensure that whoever that is checking or marking during your marking can see, indicate that this is really the point where it has to be. Remember, you guys will have a grid, so that helps us to get it right in that manner. Please make sure that you take note of that. And then the last question was like, solve for x if, let's write that down, if f of x is less equals g of x. There is no way, but this one is for interval x is an element of -90 and 0. I want to just write that down. Then we can be able to go read it off the graph, because it's always important that you can read them off the graph. Yes, you can calculate, but it might take us a bit longer than now you already have the graph. You can just read. But what does this mean? Listen to it. They are saying, look for x, where f of x, let's look for writing part. Look for x where, delete. Okay. Look for x where f of x is less or equals to g of x. What does it mean? Right. So it means we are looking into this graph where f of x is either equal or below g of x. It's either equal or below g of x. So we are looking wherever in this where we can see that g of x is actually above the f of x, or we can draw the g of x for us to read the belowness of it. So let's see. If I put my hand like this and I go like that and like this, in this manner which I'm going, where do I find the below? There's many belows that I can find between these two. So if you look at it without looking at any interval, you can see that from this point here, which we said is the point of negative, let's use this, is the point of negative, or where x is negative 67.5, up until the point where x is 45. This is below and equals to, right? If you come this other side, you also see that that also happened when you start where x is 22.5, as well as up until when it's 112.5. And again, you can see that after it reaches 135 up until 180 is also below. So, but what is it that keeps us intact, not to have all these answers, is this. Right? They said from -90 to 0. So we disregard the rest. We'll act like we did not see anything else other than this point from here to there. So our aim, therefore, will be just to check from here to there. So let's check it. What are we checking? We are just checking from -90. This is our check up until 0. That is the only place we are checking. So if you check, you can see that the only place that f of x is actually below g of x, it is from -67.5 up until 45. So how do we write that? We don't really have to do anything much. We just come and say that means x will be greater or equals to -67.5 and also less or equals to -45. Remember, these are angles, then they will be in degrees. And this is how we crack the graph code. All right, so this is how we actually get this one right. So just always remember that the moment they ask you to draw the graph, it's just simple because they know that you can then answer the question from the graph. Do not hesitate to use the information you have to draw the graph. All right, we have one more. I can't give it all because I do want you guys to try and get it done before I jump and help you into how to do it. Remember, crack the maths code from Muscular Learning. It's here to save your life, and you can be able to find your videos with many QR codes that are embedded into the book, and you can be able to actually use them to learn more. Additionally, to Musky TV and Musky itself. Just look at that, and I will see you in a few seconds for us to crack that code. All right, let's do it again. And remember, guys, one question will ask you to draw, while the other question will ask you to interpret. So they will draw the graph for you, and you need to be able to read the graph, or they will ask you to draw the graph. So you need to be able to also draw the graph. In grade 12, you need to be able to deal with two graphs in one space at a go. So let's analyze this one and see if we can crack this interpretation code together. Remember, page 289 of Crack the Maths Code. Okay, let's check the graphs of the function f of x equals a tan x and g of x equals b cos x. So for the fact that they have done this, it's actually giving us an idea to say, there is something that had happened, and I need to know what is that. If you can remember, what are those parameters and what do they do? You won. You get your marks right from plate like that. Okay, so here they're saying it's shown, and we are given the point, which it's showing that the point 225 and 2, which is in f of x. You can say this is the point they're talking about, and then they show us that the graphs do intersect at P and also at Q. Right, so if we check that properly, we can then be able to respond to the questions. Determine the numerical values of A and B. As I said, you just need to know what does A represent and what does B represent. So let's start with 6.1. In my context, A, if you look at it, it's on the tan graph, which is our blue graph, and then it shows that this graph actually has a point at 2. You can actually solve that out to get to what you're looking for, but you can actually just say that that is going to be 2, because a point A will definitely going to be 2. So you don't have to solve it. You can solve it, but not really. How will you solve it if you have to? You would have to just use the equation of f of x equals A tan x. And then you substitute whatever that you have. For example, there you have a point where you are given 225 degrees and 2. So you can substitute that in. So if you substitute that to be 2, that will be equals to A, and then multiply that by tan of 225. If you use your calculator, then that means you have A equals 2 divided by tan of 225. If you calculate that, you should be able to get the value that will be able to give you the answer then. Okay. So that is, let's see, if I do that, it will give me tan of 225. It's actually giving me 2. So you see, my answer when I said that it is going to literally just be 2, it's coming from that. So you don't really have to calculate. You can read from the graph. Right, so now that is for F, so I'm going to put F there, and then for G, we have B, and if you remember that, I did say that A and B in this context, will be representing your shift, right? That is happening, which is affecting the graph, but not necessarily. It's actually the shift that have to do with the graph moving this way, like you're stretching it up. So that was your vertical stretch. So that is what we have as A and B. So if we look at your what is this one? Cos graph. Normally your cos graph should have started right in this point. That is where we'll have just a normal y equals to cos x, which is a normal graph that we have. So y would have been equal cos x. Let's use a proper thing. Y would have been equal cos x like that, simple because that is 1, and we are not talking to that at this point, right? Simple because that would have been 1. But now you can see that that 1 has been moved and now is 4. So what does that mean? It means that our B is 4. So then you're done. That's how you answer the first question. Is it right? Yes, of course, it is easy. Okay. So determine the minimum value of G. Right, so now our G graph, we had G of x equals, now we're not going to say B anymore. We're going to say 4 cos x, right? So that is 4 cos x. But now what they're saying is that this G have an impact. It's now G of x plus 1. Somehow our G of x had an addition of something. So that means this graph that we know had a plus 2. So what does that mean? Remember the plus 2 symbol means that, let's just write it differently. Maybe we can call this one the G of x, and then we can just put a prime outside for us to remember what happened. There's an impact that happened there. So that means we have 4 cos x plus 2. What did I say 2 represent? Q, right? It represents Q, and what was the impact of the parameter Q? Parameter Q picks up the whole graphs or down. So it's either it goes up or it goes down. Because it is plus 2, that means we are going to shift the whole graph 2 units up, right? So that is what is going to happen to this thing. So when they say calculate the minimum, they are saying to us that since the minimum number was at -4, what is happening is that this is going to move 2 units up. That means that our minimum number will therefore be a -2. So that's how we get the minimum and the maximum number. Alternatively, you can come and calculate it like this. You can come and say the minimum number would have been, so what we had previously, that was -4, then we can add the 2 to it, and that gives us our -2. You can show it by calculation, or you can just look at your graph and you physically push it up or down. Okay, so that means that our minimum therefore is -2, or it is at -2. That's how you determine that answer, right? Now 6.3, they say determine the period of f of x. Let's look at it. So our f of x is equals to, it's not a anymore, 2 tan x. What do we know about tan? Tan have a period of 180 degrees. That is what we got in our very second slide. Period of tan is 180 degrees. So how do we get the period? Remember, if we're looking for the new period, I'm going to say NP, which is new period. It's equals to the period of the original or the standard graph divided by what impact of B is there. So what is the P impact? It's our half, which is given there. So we're going to divide that by a half. If you don't have a calculator, do not worry. We can do this together. this is the same as 180 divided by a half, which if I flip and times, I'm going to have 180 degrees multiplied by a 2 divided by 1, which will then give me, should be 360, right? So which is doubling what we had. So let's see, 180 times 2, that is our 360 degrees. So the period is that. Okay. Are we able to see that? So basically, this is most of the questions, or how the questions will be asked in examination for you to get it right. And Crack the Maths Code had made sure that you have this one. Just going to give you a tip to answer the last one, because I do want you guys to go and do some work. You can't just sit there and watch at me. So let's see. Show that if the x coordinate of P is theta, so they are giving you the coordinate of C there as theta, then they want you to then determine, the x coordinate of Q, or prove that that is going to be 180 minus theta. There's many other ways I can teach you how to get there if you do put a request, because that is actually on my second quadrant, and that is true. I just need you to work on it and make sure that you get that, pop it to us on our chat, or as well as in any other socials that we have for you to get it right. Do not just pass. Let's crack this together. Crack the Maths Code is here for you to get it right and get it for yourself, as much as you are trying to ask Masky for help on 072 091 0388. Keep on subscribing and share. Masky TV is here to support you with many other content that we want you to learn, using our very own textbooks with many issues. If you click on that QR code, you are going to literally find all the paper 2 different type of question papers that you can use, and it can help you to study more and more. Stay with Masky TV and Masky Miller Learning as we continue the journey of learning to your final examination in becoming the best math student. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.